revision of functions. So what is a function? Any set of ordered pairs is called a relation. A relation in which each x value produces one x, one y value. One y value is called a function and can use the function notation. Don't know why there's two words. Graphically, a relation that passes through the vertical line test is called a function. Any vertical line drawn through a function will cut it once. Don't know why there's two. Okay. So now we're going to draw this. So we're going to draw vertical lines. So see, it crosses once only, or once only. So we say it is a function. Whereas this one crosses twice, not a function, but a relation. Alright, any question? Alright, continuing on, we're going to look at the function notation. What's a function notation? A function notation that looks like this, denoted by f of x equal to 3x. So I could work out what that is. So 3 times 2, which is 6, like that. And the other one, a plus 1. So you replace x by a plus 1, which is 3a plus 3. That. The set of permissible x coordinates, the input in a relation, is called the domain. Domain is all the x value, and the something is the term given to the set of all y coordinates. For the output, this is called the range. Okay, and let's do an example. For this question, work out the domain and the range. Yeah. Alright, so let's work out the domain. What's the domain for this parabola? Anyone? Will be? Paula, what's the domain for this parabola? You don't know? It's called, it's all real x. All real x, all the x value are possible. All real x. Let's look at the range. Aaron, what's the range? Yep. Y is bigger than or equal to -3. Okay, that's good. Okay, let's move on to the next page. Now we know the domain range. We know how to describe a function, how to determine whether it's a function. Now we have to move on to the next page. Alright, so this is very important. We're going to do a summary of all the graphs that you've learned since year 7 up to year 10. Each of these, write a domain range, and then you'll be very good at functions. So first one, y equal to 2, it's a line. It's a horizontal line. Good. That will be useful. If you're doing advanced maths next year, I suggest you to keep this page because you'll use it again next year for sure. Domain, all real x. And then the range is y equal to 2 because only one y values are possible. Okay. Alright, let's move. Okay, let's move on. X equal to 2 is a vertical line. Oops, wrong place. Vertical line, x and y, and the domain is x is 2, but the range is all real y. See the difference? All the y values are possible, but only one x values is possible. Okay, so these are the two lines, and the third type of line is a line that has that's not vertical or horizontal. This is like this, y equal to x. So pass through the point 1, 1, which is x and y. Domain is all real x, and the range is all real y. Okay, so you can see there's 3 different equations for lines, and the domain range are very different. Alright, after we do lines, the first curve we learn is the parabola. So it looks like this. Okay, you learned that in year 9. That's the first curve, the most fundamental. If you square x, you get a curve. Okay, you get this graph. Let's write down the domain and range. The domain will be all real x, but the range will be y greater than or equal to 0. Okay, all right, are you good? Keep going. You should know how to do the rest of these. We've done them before, so yeah. You don't know? Okay, pay attention. All right, well, pay attention, watch my video. Okay, next one is cubic. What does cubic look like? Cubic look like two parabola joined together. So you have like this, and then you have like this. Okay, so unlike the parabola, it has what we call the point of inflection. This point here is called the point of inflection. Okay, whereas parabola has what we call the vertex. So I've labeled it there. That's a vertex. Vertex. Okay. All right. Now let's write down the domain range. Now with domain is all real x again, but the range is all real y. For cubic, all y values are possible. Okay. Good. Draw this. And what's the next one? What if I have got both x squared and y squared in the equation? What do we get? We get a circle of radius 3. Good. So let's draw the circle. Put 3 on the x. Put negative 3 on the this. Okay, just put the x and y step first, and then just join the dots. You get a circle. Okay. And of course, you can always use the end of the glue stick to draw it. That could also help you, or you can use a template. So the domain range can be found after you draw the graph. Okay, so what's the domain? Domain is x between two different values, and the range is between two values. Okay? So James, what's the domain? Have a look at the graph. What are the possible x values? Imagine between negative 3 and 3. Okay, and then Grace, what's the range? Yeah. Okay, cool. Okay, next we're going to look at the exponential. Exponential must have an x on the index. The index is unknown, so that the exponential can now be drawn. So this one 1 crosses through 1, 2. So you keep doubling. It goes up very quick. It's like this. And a very distinctive feature of an exponential is that it also has what we call an asymptote. Asymptote. Okay. And we can write down the domain range for that. So domain is all real x, and the range is y greater than without the equal to, because it has an asymptote, it never reaches 0. Alright, so that's a very important summary page. I really suggest you keep this booklet until year 11 and even year 12. Okay, it's very good summary for all the graphs. Okay, next one, hyperbola domain. Now before we do it, we just draw this. It looks like this. So it has two branches. That's a hyperbola. Alright, continue on. We're going to draw the hyperbola x and y. And then it passes through the point 1, 1. So the domain will be all real x except x cannot be 0. Okay? And the range will be all real y except y cannot be 0. I think these are all the graphs that you learned so far. Of course, there's other transformation, but you will just revise. Okay, now that's a radius. I forgot to write. That's r. Yep. Yeah. I'll need to move on, and then we'll just come back to it later on. Okay. All right. So what's the next page look like? Look like this. So we do transformation after that, and after this is this. Yeah, we'll finish very quick. Okay. All right. Hopefully you'll finish. If you haven't finished, we're going to come back to it. Okay. So we're going to move on. Alright, so you have to copy that later. Okay, good. Or you probably can work out without looking at it. It's pretty easy. Okay, transformations of graphs. So we need to know that for a parabola, this is going left to down 4. Right? So basically we have this general way of doing not just parabola for any function. When we add a number, that's a vertical shift. And then you have the k, which is the horizontal shift inside the bracket of the function. Okay? Okay, so what you do is we're going to draw this. So now there's a dotted line there. So what we do, we're going to go down 4, go left 2. So here, -2, go down for 1, 2, 3, 4. There's the location of the new vertex. Like that. And once you draw that, once you got the vertex, like knowing where the parabola is, and then you can draw. So we're going to, I think we'll cross through the origin. How am I sure of that? Because you can just do some working out. So let's do some working out. So we'll do the y-intercept. That's when x is 0. So you get 0 plus 2 squared minus 4, which is equal to 4 minus 4, 0, as expected. That's the y-intercept. And then to get the x-intercept, what you need to do, you put y equal to 0. And then to solve this equation, you move the 4 to the other side, and you square root it, which you get plus or minus 2. Remember to put plus or minus, which means that x can be -2 plus 2 or -2 minus 2, which is 0 and 4, -4 respectively. So we got -4 here. Okay, note the steps. Alright, so that's the parabola. So when it's written in this form, you do the shifting. You go shift left and down. Okay? And there's more shift that you're going to learn, so we're going to do more shift. That's a transformation of graph. So basically, the last page is the summary of all the graph, what their shape, and this page teaches you how to shift the graph. Okay? So remember all these examples. Okay, hopefully you've done. Once you've done, you're going to look at the circle. So this circle of radius 3 will be now shifted to the right 1. And then once inside the bracket, do the opposite, down 2. So go right 1, down 2. Okay, so we continue. So we're going to do, that's 1, 2, because it's radius 3. So it's this dot here. And then we're going to, this is the center of the circle. So center will be 1 and -2. And the radius is 3. So put a dot. 2, 3, put a dot. And then put a dot. Alright, so we get what we call we get a circle of radius 3. Okay, you may indicate that this is radius 3, and the center is 1, -2. Okay, so get the idea? So we'll draw the circle like that. 1, -2. Right, circle. And then try more. Right, hopefully you're all done. Radius centers at 1, -2. Right here, radius is equal to 3, 2. Okay, 3. Okay, good. So now we'll do the next one, which is the hyperbola. So again, this plus 3, like before, is up 3, and the -2 inside the x is left right 2 units. Okay, so we go right 2 units, 1, 2, and down 3 steps, 1, 2, 3. Okay, so we've got this point, but it's not really a center. It's where we draw the asymptote. We'll draw an asymptote at -3. So the asymptote will move, and the vertical asymptote will move to the right. Okay, so we've got the asymptote, and the hyperbola will move, will be here. So we have this. So it's been shifted to the right 2 units, down 3 units, like that. That's the new hyperbola. And then you can find out what the x-intercept is, what the y-intercept is. Let's do the y-intercept. That's where x is 0. So you get y equal to 1 over 0 minus 2 plus 3, which is equal to 3 minus a half will be 2.5. The y-intercept, oh, up 3 units, isn't it? I did it wrong. Should be right and then up. Oops. So I have to rub this off. Sorry about this. So it should be right and up. So my x-intercept, my y-intercept was not consistent. Okay, let's try again. So right 2 and then up 3. 1, 2, 3. Now it works. Okay. So now we'll draw this again. Over here and over here. So it crosses at 2 points. So the y-intercept now will make sense. So 2.5 here, it's below 3. Otherwise, the other one wouldn't match. So 2.5 is the y-intercept, and then we find the x-intercept. That's when y equal to 0, and we'll solve for x. So -3 equal to this, and then we reciprocal the fraction. X minus 2, so we get -1/3 equal to x minus 2, and then x equal to 2 minus 1/3, which is equal to 5 over 3, which is 2 and 2/3. 2 and 2/3, which is this bit. Oh, hang on. 1 and 1/3. Yeah. 1 and 2/3. Okay, so we've got this x and y-intercept labeled. Alright, cool. Okay, so now you know how to transform, and we'll just do one more. The next one's not as difficult as this one. Less work, I think. Alright, let's do the exponential. So this one here, this is -4, means go down 4 units. So we're going to go down 4 units. So 1, 2, 3, 4. So the new asymptote will be here, -4. Go down 4. And then you're going to draw it. So before it's 1, if you go down 4, it would be crossing at -3. Of course, they will be parallel to each other, like that. And you can find out the x-intercept for this one, because if you put x-intercept, that's when y is 0, 2 to the power x minus 4, so 2 to the power x is 4, so x is 2 by inspection. So we've got that. Right, the exponential graph is now drawn. All good. That's very good. Okay, alright, we're going to move on to the next page very soon, so get ready. Yeah, I need to keep on. Thank you. All right, so hopefully you're all done. So we've got the parabola, circle, hyperbola, exponential. So anything next to the x, you move horizontal, okay? -2 means move to the right, +2 means to the left. Anything outside the bracket, +3 means up, -4 means down. Does that make sense? And if it's inside circle, the +2 next to the y actually goes down 2 units. All right, remember all the procedures, and then we're going to move on. So you can draw any graphs without doing table of values. It's a very useful techniques. Okay, let's move on to this one. We describe also the rate of change. So we looked at this one. So it says journey 8 decelerating away from home because the distance from home is increasing, however, at a decreasing rate. So whenever it's at a decreasing rate, it's going away from home. Okay, so can you see it's getting less steep as you go? It's getting slower as you go. All right, next one, journey B. If it's moving away, it is also increasing. However, at an increasing rate because it's getting faster and faster. So we say it's accelerating. This is accelerating. It's getting faster. Okay? You should draw the graph and then write down some description. Will be useful. Thank you. All right, next one, it is going towards home, isn't it? So if it's going towards home, we say the distance from home is actually decreasing. However, as you get towards home, it's getting faster and faster, isn't it? Getting faster. So we say it is at an increasing rate. So in this case, we say it's accelerating at an increasing rate. And on the other hand, this will be decelerating because it's getting slower. So we say the distance from home is decreasing at a decreasing rate. Okay, I'll leave it up there for a minute so you can catch up. All right, so it's pretty easy. We've got 2 more pages to go. Next one is the direct proportion and inverse proportion, and then we'll do the inverse function. Okay. All right, all finished. Next page. Okay, direct and indirect proportion. Okay, so what's a direct proportion? It's a straight line going upward through the origin. So x and y. So basically what that means is if x increase and y will increase. And more specifically, if we double x, it will also double y. Or if you triple y, you will triple x. Okay, so the equation is very simple. Y equal to kx. And the symbol for that is y proportional to x. That thing is called proportional to. Proportional to. Okay, so we did that exercise before. And we also have what we call the inverse proportion, that which makes it look like a hyperbola. Okay, so it has the opposite effect. If you double x, actually let's write it clearly. If you double x, you will actually half y, right? Or if you triple x, y will be divided by 3. And you have this simple formula, y will be inversely proportional to x, which have the equation k over x. So that looks like a hyperbola, the other is a straight line. So one doubled, the other doubled, the other one doubled, but then the other one gets halved. Okay. All right, good. And then we'll do some questions. There's no questions, so you just look at the exercise. Okay, all right. What else are there? We also have restrictions on variables. So what are restrictions on variable? The denominator cannot be 0. Okay. In this case, x minus 3 cannot be 0. Means x cannot be 3. That. Okay. So we've got the denominator cannot be 0. And what else are there? We'll know how to find inverse function. How do we find inverse function? We just swap x and y. So in this case, x equal to 3y, so y is x over 3. So if the function was 3x, then the inverse function, which have the symbol f to the power -1, is x over 3. Okay, we'll learn the inverse function. Oops. Okay, good. Let's write them down. Okay, thank you. All right, next we're going to draw the graph of inverse. So what's the graph of inverse? It gets reflected about this line. Okay, so how do I reflect about the line? Reflect about y equal to x. So we swap the x and y values. So 0, 1 become 1, 0. And of course, the horizontal asymptote will become vertical asymptote. And then if you draw it, it looks like this. Okay. Or you can use that trick that I showed you. Let me try to emulate that here. I'm going to trace over this graph. Okay, good. So I've got this traced over. So I'm going to click on it. So what you do is, how do I do? You first reflect about the y-axis. You reflect it. Let me see if I can reflect. Or is there something here I could do? Which one allows me? Is it this one, not this one? Used to be away, but anyway, maybe it's here. It's a flip. Okay, flip left, right. And after you flip left, right, actually no, you don't flip left, right with. So you first have to move the x-axis to the y-axis. So you have to rotate that 90 degree, which is 90 degree clockwise, 90 degree anti-clockwise, which is not the right graph, isn't it? And then what you do is you have to flip it, and then we flip, and then we flip to the right. That didn't work. Okay, what went wrong? Let me see. Let's go back. So we did this. We solved x and y. Yeah, we flip. Up, down, left, right. I know why. Okay, I do this first. Okay, we should flip it first. Because when you flip left, right, you go like this. And then you go, yeah, like that. Okay, so it works. Yeah, almost identical. Okay, good. All right. Okay, so that's the inverse. So you've seen it in real time. Okay, let's get rid of that. Okay, good. So from here, we can learn something about the graph is that the domain of the function becomes the range of the inverse. And the range of the inverse becomes the range of the function becomes the domain of the inverse. Okay, so it gets swapped. Let me write this again, domain. So we can actually write it down, domain of the function, range of the function. We can see the domain is all real x, and the range is y greater than 0. And for the inverse, domain of the inverse is x greater than 0, and the range of the function will be all real x. So can you see it gets swapped? Okay, it gets swapped. How do I know if inverse exists? We use what we call the horizontal line test. So therefore, it does not exist. It fails. So use the horizontal line test. Okay, so inverse does not exist. So it fails. And so therefore, if it crosses twice, crosses more than once, inverse does not exist. Inverse does not exist. Okay, good. So domain can be restricted so the inverse can be found. So I could restrict the domain in here. I could restrict like this. X greater than equal to 0, then the inverse exists. And there's many ways to restrict the domain. You can also go x less than 0. Inverse also exists. Inverse. Or you could have x between 1 and 3. Inverse exists. So there's many ways, infinite many ways. Inverse. Okay, cool. All right, so we'll just leave it there so you can catch up. And now I think we've got one more page to go through. Actually, this is the last page. I just realized. That's it. Okay, thank you. All right, so you can now do the chapter review. I'll just double check. Never know. Oh, there's nothing left. Okay, good. All right. So, yeah, I'll put it back. Yep. Yeah. Okay. All right. Good. Okay. So now you can do the chapter review, and that's the end of this chapter.